And now let's go into Photoshop. And while Photoshop is launching, I'm going to bring up our good old trusty Google search here. And I'm going to pull up just bring up a human face and show work. And the reason why I'm bringing this up is because it's such an important, it's so important to understand this, like to understand what you're going after when you're building order topology. I don't know how many character models some of you have built, or if this is your first one, but this is fundamental to understand in the retopology process. If you don't understand order topology for to prepare a mesh for rigging for animation, it doesn't matter how good your model looks, it won't move. It won't. It just won't function. It won't. It's not a functional puppet. So let's see. Let's bring up chimpanzee face. So we're going to do a couple comparisons here, so you can see how this ordered topology moves around. At least what we're after when it concerns the face. And the face is really the most complex part of it. And once you get the face, I think everything else comes fairly easy. You know what? Let's grab this happy guy right here. I love this guy. He's just in a good mood. Either that or he's really pissed off at somebody. So let's go back into Photoshop. Open up a new document. Paste that guy in. I'm pretty sure this is a sign of aggression, and if I saw a chimp staring at me like this, I would hide. That is a scary smile. All right, so next, let's pull up. Let's pull up a dog head, and let's try and get a profile here. Because I think from the front it's going to be a little bit difficult to give you a good example. This will work. Have you ever seen the Galata baboon with its mouth skin? Now that's scary. You know what? I've never seen a Galata baboon, but you know what? I'm willing to look it up right now. Is it Galata or Gelata? Is the G silent? Gelata. Oh boy. Yeah, that's a scary one. Look at that. That's awesome. I want to say I've seen this before, but that's so cool. Thanks for sharing that, Simon. Look at this. How alien. I swear, baboons are not from this planet. Or maybe we're just not from this planet. All right, let's go back into Photoshop. So bizarre. All right, so ordered topology. What am I talking about? Well, in the simplest sense, I'm talking about how the topology flows. So let me start a new layer here. So you have a model, and you have a wireframe that goes across that model, right? In ZBrush, this can be very arbitrary, and in Dynamesh, you'll get tries, and you'll get all sorts of funky stuff going on in the model. right? That's unordered topology. That's just topology that is just there to simply hold the structure. When you see a decimated model for print, it's the same thing. Now, when we're talking about ordered topology, for sculptural reasons, we want something that is quadded. It doesn't matter how it flows, but we want something quadded, clean, and something that holds the form well, right? And has equal distribution of mesh density across the surface, and maybe increased density in areas where we want to hold more detail. So that's how you could think about topology in terms of sculpting. Now, when it comes to animating, what are we talking about when we talk about animating? We're talking about movement, right? So where do we think about topology first? How do we think about topology in our models? We think about it in terms of movement. How is this area going to move? And what are we giving to the rigger to anchor a skeleton onto to move that area? So let's look at the face. Let's identify large areas of movement. Right, so we have the eye. The eyelid blinks, closes, squints, the eyebrow lifts. So we have the eye region. That's one area. We have the mouth region. That's another area. Opening, just the motion of the lips when you're speaking, right? Forming your vowels. You have the nose region. Within that, you have the nostrils. She's going to start looking like a clown pretty soon, right? From the top of the head down into the jaw, you have an edge that's going to come down like this. There's going to be a little bit of hinge back here. Actually, I'm sorry, more like here, right? We'll have an edge loop that comes down here so that we can open and close the mouth, right? So we can get this motion. And everything else in between this, between your areas, large areas of motion, is really trying to cleanly resolve where these regions meet. Right? So if we look at the eye, I like to think of, like as far as structure goes, in a region, like a region of the eye, for any animation to take place, how many edges do we need? Right? We need 3 edge loops minimal. The way that I like to think about it is we have one edge loop, like you think of 3 edge loops stacked together. Right? So let's make I'll draw a quick cylinder here. And I want to bend this cylinder. I want to rig it. So right now with 2 edges here, I can only shift these up and down. I can't perform a bend. In order to have a bend, I need an edge loop in the center. Right? I needed this hinge. So now I can move this up and bend it. Now it's not going to be a pretty bend, but it'll give me a bend in that area. So I need a minimum of 3 edges. And I'll talk about this more next class. But think about that concept. Think about your arm, the way that your arm moves. In the center, right? If this is your hand, there's your wrist, there's your elbow. This is your elbow joint, right? That's where the bend takes place. And the way that I like to think about these 3 edge loops in terms of animation is you have, if we're going to bend the front portion of our arm, we have a static. So this is our static. This is our mover. And the joint is our negotiator or our hinge. Okay? So think about that concept as I move forward talking about ordered topology for animation. And we are going to run a little bit over, but I want to get through this for you guys because I think this is absolutely fundamental. Let me just Control Z back or erase this. I'll just erase it. All right, so what does that mean in an area like the eye? Well, if this is the border edge of our region, actually it's a little bit more out from that, but if this is the border edge of our region, it means that we have a border edge here. The next border edge is going to be along the eyelid, and then we need an edge loop to negotiate in between. So the way this would work is you have, and these exchange places. Sometimes this is the mover, sometimes this is the mover, or sometimes they're both the mover. But you have to have a negotiator in between. So for each region, you need a minimum of 3 edge loops to perform any action, or to have any action take place. So in the case of the lips, ridge of the lips, edge loop inside. So if you're trying to come up with a really low poly mesh, like a super low poly mesh, this is the absolute minimum that you'll have to deal with, right? This is the very starting point. Same thing in here. You'll want 3 edge loops to move around in here. You want 3 edge loops in here to move the nostril. You'll want a minimum of 1, 2, 3 edge loops to move the jaw. Now, we're not going to go with 3 because 3 will typically produce fairly clunky, chunky animation, and we have beautiful things like the Xbox One, and PS4, and awesome PCs with fantastic NVIDIA graphics cards that can handle a lot more. Unreal handles, I think, I forgot what the last poly count I heard for Unreal. I'll bring that back for you guys next time we chat. But I know that like for a heroic character, you can go upwards of 80 to 90,000 polys in one character. And that's with other secondary characters on the screen, including the environment. So modern platforms can push a lot more than they could. Now, does that mean that you want to just blow the bank on your poly count? No. You always want to aim on the lower end. I'd say don't use more than you have to, right? You have to strike a balance between performance and artistry. You want to get somewhere in there. So the poly count that I'm aiming for in my Griffin is going to be somewhere between 15 to 25,000. And I probably want to go closer to 15 to 10, just so that, you know, it's a mount, it's not a heroic character, it's an NPC roaming around in an environment amongst others, and that's going to stack. You know, I want to reserve that like higher poly count for my heroic character or for my boss. So what does this mean? Why did I pull up the other creatures? So how do we translate this into what we would use on a creature? How do we translate this? So I'm teaching you just the fundamental rules that you need to follow when building topology. And just keep this in mind as we go forward into actually retopologizing, because if you're not getting it now, you will get it as we go. So, and if not, I'll do my best to re-explain and re-demo so that you guys can understand it. So I'm going to color code the regions here. So let's do a new layer. So we have the eyes. We have the mouth. This is where she starts looking like a clown. We have the nose. We have the nostrils, right? So those are the major regions, and I'm excluding this large one, right? Actually, let's not exclude that large one. Let's just go ahead and make that orange. Why is an orange and a banana not a yellow? All right. All right, so there's that region. So now let's look at a primate. Let's look at an ape, something other than human. So we had red for the eyes. How does this translate? This is fairly easy to see, right? Eyes. What color do we use over here? Blue for mouth. The mouth. The nose. The nostrils, right? And then we had our jaw. All right, there we go. Right, so that's how it translates over to primate. Now let's look at a dog. Totally different facial structure. Same rules apply. And I'm sorry if I'm beating a dead horse. I just want to make sure that all of you understand how this translates between each other. Eyes. Mouth. Nose. And nostril. And then let's do that hinge. And the hinge we're probably going to see on the bottom. So we're going to start back here and sneak underneath here. So does this make sense to you guys where we're going with this? Is it clear what I'm talking about as far as like how the topology flows? All right. Claude, you good with this? So my point is that you're not, if you know how to do a human head, you know how to retopologize a human head, that's great. You can do 1,000 human heads, and honestly, you probably only never need to do like 3 and then just duplicate it and resculpt them. But what happens when you get something like, I don't know, let's pull up something from, I don't know, Mr. Neville Page. So how do you tackle that, right? How do you tackle this? You have to think about each one of those forms in terms of motion, in terms of regions, identifying those regions, correlating regions. This moves like an eye. This moves like the mouth, right? If we look on the side here, we can go, okay, this is just a star-shaped ridge to the mouth region. We can treat it that way. We can treat these as limbs, right? But you have to sort of understand the fundamentals of doing something that's bipedal and humanoid to tackle something like this. And you have to understand just the fundamental laws of motion with regards to animation and making a successful puppet. This wouldn't be so hard to retopologize, but when it gets so alien and bizarre, I mean, you hit stuff like that, then yeah, I mean, it can become a challenge to go, well, how do I really tackle that? You know, how do I really deal with something that has a 6-way split in its mouth, or you know, you're dealing with something complex. You know, and then you're going, okay, well, these are all eyes, and let's look at this. These are actually just fingers, right? So those would receive the same topology as a finger. So when you're doing creatures, it's really just a matter of comparison. And you're going, where can I use the same tricks that I use on a human and apply them across multiple creatures? So next class will be in Maya retopologizing. We'll get into those modeling tools in 2015 using QuadDraw. Do you guys have any questions for me before we go? Because I'm going to go ahead and wrap it up right now. Give you guys a couple seconds, and I'm just going to draw in some geometry here. All right, Simon. Cool. Claude, Ash, Manuel, Marcos, Christian. All okay, fantastic. So I really want to see your guys' progress. I really love seeing your progress. It gets me excited for each class, and I'm just like, oh man, this is dope. This is phenomenal. I really want to, I want to blow your work up. I mean, it's really good stuff that you guys are producing. If you guys are up for it, just let me know if you don't want me to share it, because I can get over Zoom and be like, oh my God, look what this guy's doing. It's awesome. But anyways, I'll see you next class. Thank you for being with me here today, and thank you for taking part in this venture and creating these creatures. You guys have a fantastic day. Have a beautiful day tomorrow, and I will see you on Friday.